All right. Well, you all are in for a special treat on this session. We have some of the, I think, actual experts when it comes to building intent-based products. And so what we are going to talk about is really just diving into, I think, actually a couple of underexplored areas around intents, like not just defining them, but really talking about how they can be used and what people don't understand. So first, let's start off, well, I guess just a quick round of intros. So we've got Adrian up here from Anoma, we've got Jake from CoinFund, and then we've got Chris from Across. If you guys want to maybe just talk a little bit about yourself and your project, and then we can dive in.
Yeah, I'm Adrian from Anoma. Anoma very much cares about building a distributed operating system for generalized intents. I think intents are literally the solution for everything it requires counterparty discovery, which is like 99% of the stuff we want to do. I mean, in an earlier talk, Zaki was talking about how all of these systems are coordination systems, and coordination fundamentally requires more than one person. And so anything that requires more than one person needs an intent-based system.
I'm Jake Brukhman, founder and CEO of CoinFund. I'm an engineer, generalist technologist, been working on focusing on blockchain investing for the last 9 years or so. CoinFund is an early crypto fund based in New York, Miami, and Boston, and looking at all areas of the blockchain space. But I primarily spend my time in deep tech and blockchain infrastructure.
And I'm Chris, work at Across Protocol as a research engineer. I've been with the parent org UMA protocol for close to 5 years now. And yeah, Across is a intent bridge. Our primary use case of intents to begin with is high-speed asset bridging, kind of identifying that the friction point that users experience today really is moving assets, and that's where we're starting.
Awesome. Well, yeah, so what I wanted to kick it off with is where you guys, like, since you spend a lot of time kind of, I think, kind of like talking about this product with, and this solution with people on crypto Twitter and broadly in this space, like what are some of the common misconceptions, like the things people aren't thinking about right when they think about intents?
Yeah, I think a lot of people think that intents must be limit orders and will only ever be limit orders. I think this is certainly not true. I think certainly a lot of the early use cases have intents behave like limit orders, but really intents, it's all about generalized intents, because this is where you get actually most of the composability from. The ability to have not application-specific intents, but rather general intents, so that solvers can compose across like this safe multi-sig intent plus the sort of Gitcoin funding intent plus limit order intent. This is where I think you'll see the actual 10x unlocks of intents, because we're just going to make everything about 10x more composable, and then probably another 10x by also making this cross-chain composable again.
I would say people have a really poor understanding of what intents are. And one of the reasons is that there's a lot of manifestations of intents in the market. Like here we have Across Protocol, which is a very specific, dedicated implementation of intents for a specific purpose, which is bridging across blockchains. Here we have Anoma, which is a more generalized intents framework that's meant to kind of encapsulate that functionality in general. You have other projects in the market that, for example, are creating intents in the context of their own blockchain. You have others that are creating intents in the context of not so much interoperability technology itself, but an interface to aggregating a lot of different blockchains into one, like intents functionality. And so I think until people can really get their hands on some of these technologies, it's going to be a little bit opaque for people, but I hope I helped to disambiguate it a little bit.
Yeah, I think I have two answers here. Like the first one is from like a technical perspective. I've heard a lot of misconceptions that intents are like incompatible with other scalability or like account abstraction solutions. And I kind of to your point earlier, like I think that's not necessarily true, right? Like these systems can be designed to be modular enough that they're compatible with like other components. And then related to this also from like a more technical perspective, I've heard like takes that intents are like strictly more difficult to integrate with versus other types of systems. And I think that's also a misconception a lot of the time, because the interesting thing about intents is that they push complexity to the edges, right? Like the relayer often is the one, like, or the solver, or the whatever we want to call them depending on the system, is the one taking on like the path to define the execution, right? If we're looking at like a swap, for example, if you're not using an intent system, you need to define like the full execution trace. Whereas if it's an intent, you just define the output and push that complexity to the edge. So that actually makes integrations often easier for like intent systems versus other kinds of systems.
Actually, I think, like, now thinking about this and also listening to your answer, it's like, intents aren't like, in this space we kind of have this idea that it always must be like, well, X replaces Y, that it's always against something. Intents are just very orthogonal. Like, intents are a very new thing that just enables new things. It's not, intents aren't going to replace VMs, for example, like virtual machines. Like, intent machines and VMs aren't competitive. You can build intent machines on top of virtual machines. It's like, I think in this space you always have to be very careful to not fall trapped to like, oh, my word must be replacing your word because this is the only way the attention shifts. It's more like, this is like, we can build a lot of these things on top of each other without having to compete there.
Yeah, I think that's a good distinction. So you guys both, I mean, all of you pretty much mentioned like swaps as like, I guess, the current most obvious implementation of intents. Like, where do you think we're going to start seeing, or already are starting to see, some other applications of intents?
So maybe I'll go first, just because I think we have like level 1, and then you can go to level n. So swaps beginning, but the like key feature that we have in Across is this thing called Across Plus. So that's basically like, in simple terms, like bridge plus action. So that's like beyond swaps, right? So you moving between two chains, and then you like call some arbitrary call data at the end of the bridging action. And our settlement system is verifying that both the bridge or swap plus this like final output have been fulfilled the way that the user had specified. And an example could be like, I don't know, bridge to a chain and then deposit into a money market, right? It's like, it's marginally additional functionality, but for a lot of use cases, this is actually like the secret sauce that they need, right? Like, your user is at like, I want to buy the NFT, and they don't have assets on that chain, but they have assets on Base, right? So then like the bridge plus swap action there is like, okay, detect that they have assets on the other chain, pull the assets to the target chain where they want to go, and then perform like one action, right? Which could be like combinatorial, but yeah, so that's like the step 1 for us, and I'm sure like Anoma has a lot more to say on that.
All right, I can sort of go all the way to step n, and we can see if we get there via inductive reasoning. So intents, what they generally do is they abstract execution from state layout. So in an intent, you define specifically, I currently have state A, and I'd like to have state B, and I actually don't care how I transition from A to B, and the system just checks that, or like wherever the intent machine is sort of currently running, for example, this could be on Ethereum, this could be on Solana, this could be on a global Anoma L1, it could be anywhere where you can implement the intent machine. The system just checks that your constraints were adhered to, right? So like that you currently started from state A and only got to state B. And so with the limit order, for example, this just looks like I currently have some ETH and I want at least this much Bitcoin, and that's then your intent. And so you can imagine now the number of use cases you can build. Anything that requires counterparty discovery where you don't have the other leg of the sort of state transition, where this could be I have A for B and someone else needs to have B for A in order to make this settleable, but this doesn't even have to be 1 for 1. It can be like I have A for B, someone else B for C, C for D, D for E, and then lastly E for A. One very common use case that I think most people don't think about, but which is an intent system, is the rollup. Like any sort of L2, it's clearly an intent-centric, it's an intent system. Because, again, you just collapse a number of state transitions together into a single state transition. The use case that I'm pretty excited about are around, for example, Gitcoin, where we want to have the ability to actually have very decentralized applications. So without having to rely on someone like sort of centrally in a Google spreadsheet running the computation of which project should get funded and then executing it, we can rather say, well, with intents, we all commit to if and only if this project actually gets funding, does our money get pulled from our accounts, right? So you can do these kinds of things. Another very simple example is the Gnosis Safe. 2 out of 3 multisig is an intent-centric system, but currently you send your intent, your partial signature to the Gnosis Safe server effectively, and the last person pulls it from there. In the future, you can just send this to sort of the Anoma intent gossip network, and then whether your transaction or whether your intent is going to be settable on Ethereum or Solana, I don't actually care. Like, it's just common infrastructure that handles generalized intents that can then be executed against Anoma as an operating system.
Yeah, it's a good question in terms of applications, but maybe like let me give you a view of how intents might impact smart contracting itself. Like, I definitely talked to projects, at least some projects in the market that have this approach. But basically, today when we implement dApps, right, we're using like imperative programming or writing Solidity, writing smart contracts. With intense networks, there's an opportunity to Adrian's point, to like abstract the execution of that. What comes in intense networks is a kind of an execution network, a relay network, where we're effectively like abstracting the execution away. And so what we can actually go and do is go from imperative programming to more declarative programming. Probably a lot of people in this room are technical, but for anyone who doesn't know what that means, it's essentially a way of like defining the functionality of your program through constraints, and then offloading the implementation of your contract to a network that you don't really care how they kind of fit within those constraints, except as long as they deliver the output that you want. And so there's kind of this opportunity to, again, like change the way that we program applications longer term, and that potentially opens up, maybe more accessibility to development in the blockchain space, and sort of like smaller applications, more creative applications.
Actually, I think this kind of declarative intent programming is going to make application development an order of magnitude easier than it is right now. This is, I think, like one of the biggest dev unlocks we can possibly currently work on, which is just when you think of intents, your development experience just becomes way better because you don't have to worry about like what specific opcodes exist on which specific platform.
I was going to say, maybe we can give like a concrete example of like for example, if you're building a DEX, like an AMM today, you kind of have to go and do all the work. You have to go and define the curve. You have to go and define like what pools there are, right? But in a more declarative programming setting, how would you do this?
Yeah, so the way to actually think about this is in a more declarative setting, for example, using Juvix and Anoma, you just write like, I currently have this state, and I'm willing to hold this specific other state, given some constraints. And you really write like, I'm willing to sell my ETH for Bitcoin if the price is above 4K and the weather in Paris is nice. And if the weather in Paris is bad, then I want to hold, right? And this is literally just what you write down, and then solvers sort of take this constraint and then try to do constraint solving, which is they take a number of these intents, and then they see if I combine them in different ways, do I get something that effectively goes correct afterwards? And if it goes correct, then you can settle this as a transaction on chain. When it comes more to application development, it starts looking a lot more like what constraints do you care for your program? For example, in an AMM, you'd care about some specific curve being a tier 2. But it's not like, in a theory, we very much write like 1 + 1, then set NFT equals green. Like you very much like outline the individual compute steps, which makes it very complicated to reason about sort of what possible states your program can be in. Whereas with an intent, with a declarative model, you just define like what possible states can my program hold, and then like anything that doesn't violate those states is like a correct execution of the program. And this is actually, now that we think about that, intents will revolutionize ZK. And I think most of the ZK people don't yet know that they will need intents, but like ZK pushes state to the edge of the network and hides the compute, right? And so we don't currently have a good model on these systems for how to like express, for example, that I'm willing to trade A for B, but privately, because like we can only settle fully fledged things on chain. And so what intents actually allow you to do is you can say, I'd like to do this kind of state transition, and no one knows who I am, but we just modify the state, and this is my starting state, and this is my ending state.
So between ZK and intents, are smart contracts like going away?
No, smart contracts will still exist, but more as a verification tool. Like you just define what specific things your program cares about, and then it verifies it. It's actually much closer, like maybe in the future, most smart contracts just become ZK verifiers. That I can totally see. Sort of pending some performance constraints.
Yeah, it makes sense. I mean, it seems like we've got, on the one end, kind of like today, most of the environments are imperative, and you have protocols like Across and Across Plus that are kind of iterating on top of that and like designing some solutions on top of that. And then on like the other end of the spectrum, you have kind of Anoma, where you're building for the declarative future. What does the transition period look like, and like what do you think are the steps beyond maybe Across Plus on the way to building towards everyone just using the Anoma type of approach, given that most imperative layer ones are not going away, at least in the next few months and years?
By the way, I'll start off with, I'm a huge fan of Across, and I use the protocol every time I want to move across chain. And sort of like, Anoma's goal is not to replace or compete with Across, for example. It's just like, if you eventually want to have a much easier time building Across, like Anoma just provides a bunch of like underlying stacks for you to like not have to write a bunch of Solidity contracts in order to like make this happen in practice. This is really the way I think about Anoma, which is it just makes existing paradigms easier to implement. It is not there to replace them. It does not compete with Across. And we sort of historically saw this. Like you could build a lot of things on Bitcoin using Bitcoin script, but building that was very difficult. And the EVM in Ethereum like didn't sort of replace those systems. It just made them easier to build. And as a result, over time, many more people started migrating towards sort of the EVM approach rather than Bitcoin script approach. And I think we'll see the same thing with intents, that people start migrating more towards the generalized intents because it's just going to be easier to build there.
Yeah, I mean, I think what I'll say there is, from our perspective, like it's very much trying to take the most pragmatic approach that is like, you know, we're entering the world of 1,000 rollups and they're proliferating everywhere, and there's like an immediate fragmentation problem. Like we fixed scaling on Ethereum, that's great, but we also made the UX like 5 times worse in the process. So like, how do we unify that in the medium term, right? So that's very much like our intent for now. Excuse the pun, but yeah.
Wait, maybe, can I ask a question? Like, there's usually this trade-off we see in tech where very specific implementations, they're specific, but they tend to be more efficient, and then like very general things are more general, but they tend to be kind of like slower and less efficient. Do you see that trade-off in play in intents as well? Like between generalized intense networks and specific implementations?
This is certainly going to be true on the solver side. Sort of the more structured your intent can be, the easier your life it will be as a solver, right? Like you can imagine, I know you can just write like, I currently have this completely opaque state encoded in my own encoding format, and I'd like to go to a different kind of state and encode completely differently. That's very difficult to solve because the solver doesn't have a lot of structure to go by. So in that sense, generalized intents make things slower. Mm-hmm. Unless you start agreeing more on the intent standards, like Cross does, and like then if everyone just agrees this is what a cross-chain transfer looks like, solvers actually have a much easier time sort of dealing with that kind of structured data.
Yeah, and I think the structure is key, right? This is why we created this EIP with Uniswap, and why we're like trying to like push like one unified way of specifying these things. But yeah, there's obviously like a bound on how expressive that can be. But again, just being like pragmatic, like users primarily today want to move assets. That's what they want to do. And applications that need to move state, or like intent systems, like maybe in the future will be the right solution. But for now, that's like still to be defined.
And maybe like one last thought here, which we didn't mention yet, which is that solver networks tend to be free, open markets, right? And markets are actually like really, really effective at optimizing and making problems efficient. So we've definitely like seen that in Across, for example, as your time to execution has gone down dramatically as the network.
Yeah, this is a key thing for us, right? And like also it like aids with decentralization and permissionlessness and like anti-fragility of the system overall, right? Like enabling anyone to be a filler is like a critical component. And then you kind of push the complexity to the settlement layer, which we didn't really talk about here, but that's then like the hard problem is like, how do you settle the intents at the end of the day?
On sort of, you want to have open networks here for solvers. I think the really important thing to understand is you should have composable solving. Like if you have an intent from A to B, and someone from B to C, a solver needs to be able to sort of create a partial solve. Because otherwise, especially with generalized intent systems, you'll end up in this world, which we currently see for the rollups, which is one mega solver. And sort of like all the rollup interop is currently effectively proposing, well, let's just get really single large solvers to like do all the interop between all these different rollups. And it's because fundamentally no one has thought about how do we do composable solving. So especially as we move towards generalized intents, we really need to think about using composable or building systems that enable composable solving so that we can have many competing solvers that compete in their own niches, but we can still sort of like compose these solutions on top of each other.
Awesome. Well, guys, unfortunately, we are out of time, but thank you so much for all those insights. And hopefully the developers out there got a lot of thoughts about how they can utilize these systems. So please make sure to check out Anoma across, and then I'm sure CoinFund has funded a lot of these protocols as well. Great. Thank you, guys.